What I want to do now is show you how to kind of work with other types of files, loading them into R, exporting them from R. And the way that I want to do this is basically work with CSV files, which is a comma-separated file, a kind of very common type of file format that data is often saved in, and one that you can save your data as. It's a little bit better than a basic Excel file. It's more general. And so let's start working with this so I can show you how the working directory works and how to kind of create and load these types of files. So let's calibrate some dates using that rcarbon package. I want to calibrate some dates in the data set that they supplied, so I want to view that data set again. If I type in the name of that data set and I use the view function here, it creates a new tab as we did before that contains this EMEDYD data set. You can scroll across and scroll down. You can see all the different columns they've got: longitude and latitude, country, site name, material, the date, the error range on the date, and all of the many different dates that are contained in this object, in this data object. So that's what we want to work with. What we want to do is figure out which columns we need, because if we're going to calibrate some of these dates and create an object, we need to know what the columns are called. You can use that view function, as I just did, and see what the columns are called. That's one option. But additionally, you can also use the call names function. I prefer this because it allows you to just look down here in your R console and see the 10 different column names from this data frame. That call name function is really useful in that sense. So now we know what the column names are. Let's calibrate just dates from one specific site. Otherwise, it would take a long time to calibrate all of the many thousands of dates in this object. If I want to see the different sites that are contained in this, I can see here that there is a column called site name. And what I can do is use another cool function called the unique function. And if I type the emidid $, and then RStudio, being helpful, prompts me with the names of all of the different columns once I type the $. And if I select the site name column, what I'm now asking R to do is show me all of the unique values of the site name column of this object. If I run this, it now spits out 196 different site names. It looks like these are the site names that are contained in this data frame. You can scroll up in your R console and see all of them. There's a lot, of course. What we can do is just pull out one of them. So let's just look at the site of Jericho, which is a famous archaeological site in this region. Let's create a new object called Jericho, and I'm going to pull out just the Jericho dates from this emidid data frame. I can do this using indexing. So if I type the emidid and I open up my brackets like I'm going to index it, I then need to type the rows and the columns that I want. I want all of the columns, right? Because the columns, as we can see if we run the call names function again, that's the lab ID, the date, the material that was dated, the country, the region, latitude and longitude, all of that. That's all important information. I want to keep all of that. So what I'll do is, where I've got my indexing here, the rows and then the columns, I'll just leave the columns blank. If I leave it blank, R interprets that as me wanting all of the columns. So after the comma, I won't type anything. What I want to type before the comma then is I want every row of emidid for which the date is from the Jericho site. Now, you don't want to actually scroll through that huge emidid object, right, which has thousands and thousands of dates, and try to find the one from the Jericho site, all the different ones from the Jericho site. So what I can do is actually use a logical operation for this. Instead of typing a number here, like 3 to 7, if I wanted rows 3 to 7 in all columns, that's what this would do. But instead of just typing 3 to 7, because I don't actually know where these Jericho dates are, I want to create a logical operation. So within the emidid object, I want all rows for which the site name of this emudid object is equal to Jericho. Now, when you're writing these logical functions, which is this bit right here that I've highlighted, you need to use double equals signs for most purposes. And this means basically that for every row for which emudid $site name, that column, is equal to the value Jericho, which is in quotes because it's a word, give me all of those rows, or rather I should say only those rows, and give me all of the columns of emudid. Right. If I run this, I've now created a new Jericho object, which you can inspect here by clicking on it, and it only contains dates from the site name Jericho. If you scroll down here, you can see that. All of the site names in that column are Jericho, because I told R to only do that by this little bit of code right here. Within the emudid object, I opened up my brackets to index it, and I said pull out just the rows for which the row name of this column is equal to Jericho. So that's how I've got this Jericho object created. This is a really useful way to pull out subsets of data from within data frames that you're working with. Now let's actually calibrate these dates. Let's do jericho.dates, assignment operator. I want to use the calibrate function, which we looked at the help file for, and it's still pulled up here from within the rcarbon package. And if we look at this help file, what we see is that calibrate requires really two key arguments, x and errors. We can read about those under the arguments section here. X is the uncalibrated radiocarbon dates, and errors are the standard deviations corresponding to those dates. You can add more arguments in here if you want to specify a different calibration curve, if you want to specify offsets, normalization, various other things, you can do that. But at the basic level, we just need those first two arguments. So we need the dates and we need the error ranges. Now, if we look at that emudid object, we can pull that up again and see the dates are contained in the CRA column and the errors are contained in this error column. We can also do that by just looking at the call names here using that function, CRA and error. So what I want to do then is say, okay, feeding the calibrate function, just those two columns, I want to take that Jericho object that we created, which is just the dates from the Jericho site, type $, and select just the column CRA, which is the uncalibrated radiocarbon date. Then type comma, because that's the first argument that we're feeding it. That's the argument x. We could also type x equals that. The second argument we want is the errors argument. Now, as I said before, because the first two arguments in the function are x and errors, we don't actually need to type x or errors. We can just go based on the order, which makes things a little bit easier to read, but perhaps a little bit less clear. So it's a bit of a judgment call on what you prefer in certain contexts. And then I want to feed it the errors column from that Jericho object. So I'm taking Jericho $CRA, which if I run just that, these are the dates, the uncalibrated dates. I take Jericho $errors, which is spitting out an error message. It's saying there's no such thing because I typed errors instead of error. Error is what that column is called. If I run that, we have the corresponding standard deviations. Now if I run this whole thing, it's going to calibrate these dates and assign the output of calibrated dates to a new object called jericho.dates. I run this, that function just ran. This function has a nice little progress bar, and it messages you when it's done, which not all functions will do, but that's very nice. And now, if you double-click on the Jericho dates object or inspect it in your environment, you can see that we've got all of this very complicated output that contains the calibrated dates, but it also contains a lot of other stuff that we don't need. Looking at the structure of Jericho dates, you can see that this is a very complicated type of object. We don't want all of this. What we want see if I can find it, is just the calibrated date. So you have to scroll through and kind of find where it says $, whatever the output you want is. If you wanted to just pull out that specific thing. This complicated object type can be accessed in other ways, and what we really want for our purposes here, let's say, is to just pull out the median date. There's another function in the rcarbon package, which is cool, called the medcal function. And if I feed this the Jericho dates object that we just created by calibrating those dates, it will just spit out the median dates. Now if I run this and inspect the Jericho.meds, these are just the median values for all of those calibrated dates. This medcal function is really cool in this package. It allows you to do that. Of course, you could have pulled up the help file from medcal and read about it before running it, as you should do before running a new function. So now we've got these median calibrated dates. But of course, this is just a series of dates. Really, you should keep these attached to the lab number so that you know who ran the date and have some sort of way to identify where that date came from. So let's create a new data frame. I want to call it the Jericho dates. Calling it Jericho dates, as you can see, we already have an object called Jericho dates, which was the calibrated dates. If I make a new object called Jericho dates, it will overwrite that object. And I'm okay with that for now. Let's do data frame. Let's make this column called lab number. And from that Jericho object that we created before, I want to pull out the lab ID. So this will create a new column called lab number in this Jericho dates object that contains the lab ID from that original object that we created. I then want to pair this with the median dates that we just calculated using that medcal function after the calibrate function. Feeding that the output from before, we've got the median dates. I want to plug that into our data frame. Now if I run this and inspect Jericho.dates, I've got a data frame with 42 rows, 42 median dates with the associated lab numbers in the first column, and the median date in the second column, which is pretty cool. You can inspect it here by clicking on it, same as down in the R console. This is the output of that. Now, let's export this. All right, we've got this data frame called Jericho dates, and say I want to save it and attach it as supplementary information to a paper that I've published, or say that I want to share it with a co-author of mine so that they can do some work on it. What I can do is use the write.csv function. If I type write.csv, open parentheses, Jericho dates, this is going to take the Jericho dates object that I just created, that data frame, and make a CSV out of it. I then want to type comma and name the CSV. I'll call it Jericho_dates.csv. It's important to put the file type here. It's a CSV file. If I run this function, I've now created a CSV file that contains that data frame. Now, as we discussed before, I set my working directory to my desktop. Remember using session, set working directory. So this CSV that I just exported seemingly is just somewhere on my laptop, but I know that because I set my working directory to my desktop, it's on my desktop. That's where this write CSV function sent things. So you'll be able to find this file on your desktop, which is really cool. And of course, I should mention that if you then wanted to import this CSV file from your desktop, you can do that as well. If I do input data read.csv Jericho_dates.csv here, this read CSV function, because it's assigned to my working directory now, this CSV function knows where to pull it from. So I've just now created an object called input data, which contains that data from the CSV. So I sent it to my desktop, and then I pulled it back in with this read CSV function.